Howdy, and welcome. We will be discussing the proper standard operating procedure for water sampling, presented by IFE Consulting. Materials needed for this procedure are as follows: a dipper, baler, gloves, goggles, safety vest, paper towels, RO water, glass container with PE screw lids, ice packs, cooler, chain of custody form, stakes, X-Stick 2, checker by Hanna pH meter, non-smudgeable pen, string, tape measure, lab notebook, and seals and labels. We will be following IFE Consulting as they sample a runoff creek located on the Texas A&M golf course. Starting downstream, select a starting point of where you wish to sample. Use a random number generator to create a distance that each sample should be from each other. In this case, 11 feet was used, totaling in 33 feet for 4 different samples. At each marking of 11 feet, a stake was placed to mark where the sample should be taken. Sampling from the creek should be done with a dipper that immediately goes into a sample jar. This is best accomplished with a 2-person team, as shown. Immediately following sampling, conductivity, salinity, and pH should be tested using the X-Stick 2 and the checker by Hanna. Once initial tests have been done, samples should be sealed and labeled with the name of the sampler, date, location, and sample ID. Time of the sample and results of the initial testing should be recorded at this time as well to ensure integrity of the samples. This is also when the chain of custody begins, and the sample should be stored in a cooler. After each sample, the X-Stick 2 and the checker by Hanna should be washed out with deionized water to ensure the next samples are not contaminated. Additionally, the dipper should be cleaned after each sample is taken. This is also done to ensure contamination between samples does not occur. In addition to the 4 dipper samples taken from the creek, a rinsate and critical point samples should be taken. Before washing and cleaning a dipper, after a sample, wash the dipper with deionized water, collecting the water flowing off in a jar as its own sample. This sample is useful as a measure of how well equipment is being cleaned during the sampling. A critical point sample is used to be able to identify a possible source of contaminants. In this case, the drain that creates the creek was used as a possible source site. With unusual terrain, a new method of sampling was needed. A baler was chosen as the most appropriate means of obtaining a sample. Balers are lowered by a string to the water where it can fill up with the water, while a small ball on the inside of the tube prevents water escaping while being pulled back up. After sampling, proper testing should be done on the sampling inside the laboratory. We chose to test the dissolved oxygen, phosphate concentrations, nitrite concentrations, total chlorine, and fecal coliform presence. Dissolved oxygen is determined by a chemetrics testing kit. A sample tube is placed in a new jar of the sampled water, and the tip is broken, allowing a small amount of water into the tube. Once fully mixed, the color of the tube can be compared to a scale to determine the dissolved oxygen content. To perform the other testing procedures, 3 small flasks must be filled with the water sample. Using each detecting device, the sample are first blanked and then small packets of chemicals are added to the samples. This causes small color changes that are picked up within the device, and a proper reading can be determined. This reading will show up on the front of the device as shown. The final test is done as a fecal coliform test. 10 microliters of water sample is added to agar plates. The sample is then spread around the plate. These plates are then sealed and stored to check on later for coliform growth. This concludes our presentation of water sampling standard operating procedures. Thank you for watching.